On June 2nd and 3rd, 2011, the Center for Design and Geopolitics held its first annual conference in La Jolla at Cal IT2, the California Institute of Telecommunications and Information Technology, on the campus of the University of California at San Diego.
All right, thank you for being here. This is the discussion section after the panel, Data as World, World Image, World Making. And I'm here with Lev Manovich, Kelly Gates, and Molly Wright Steenson. And we're going to be giving them an opportunity to go in more depth about their talks and also talk with one another about some of the issues they raised about data, identity, knowledge, and the world. I think one of the interesting things that came up for me, and I'll take a moderator's prerogative to give a sort of a general topical question to all three speakers, is a kind of gap between different ways of knowing. This gap was featured in Lev Manovich's talk as a gap between we call it the ethnographic and the
datographic.
Datographic.
Ethnographic and datographic.
Ethnographic and datographic.
Ways of knowing.
and the way that sampling, or what Kelly might have thought of more as total information awareness, can address that gap, and what other ways we can redefine that gap. Kelly Gates herself looked at different ways of knowing the face, computationally knowing the face, and the way these kinds of knowing reflect on identity, presence and absence of the body, and the way a state apparatus can know or not know things like what is a terrorist or what is the population. And finally, Molly Wright Steenson, looking at the different configurations of the architecture machine, looked at stages in Negroponte's conceptualization of how machines which might know us or might converse with us or we might live within moved towards a series of experimentations with user interfaces, hunching, seeking, and groping towards some kind of shared understanding or conversation, and questioned the construction and the limits of that potential understanding. So my question to the group to kick this conversation off is, in looking at the three panels and in thinking about your own characterization in terms of a kind of a gap, how do you think your work in this panel addresses this idea of making the world, and what role does this gap play?
Does anyone want to start?
I could start. I mean, I was presenting more specifically about the work of Negroponte, but one of the things that I find most interesting about him is that he had a real ethos. He called it an ethic, and the majority of the architecture machine and soft architecture machine is trying to grapple with that notion of a gap, of what principles should guide an architecture machine. It's something the bibliography on the book is stellar. I mean, it's and it's full of a bunch of references, and the fact that it never really renders properly. I mean, it doesn't provide the fidelity he hopes for. The other gap, I think, is when you start looking a little more critically at what some of those projects were, and I couldn't help but, as Kelly was presenting, to start bouncing some of what Negroponte was seeking to do, trying to combine intelligence with the body, and your statement, we have no body, we are only a face, and seeing that maybe some of these gaps are really playing out now in some very insidious ways, in a lot more maybe harmful ways.
One of the things that, this is not in response to the question, but I was just thinking about Negroponte, because he has this great quote about your face being your display. He says, your face is your display device, and your computer should be able to read it. Yeah. Which I think, that was kind of a springboard for me thinking about what exactly that means. And so our faces are like he's envisioning as our faces as these pixelated streams of data, but my argument is they're sort of more than that. They're also kind of parts of our bodies and ourselves and situated in social networks. And that I think the gap that interests me is from when you said gap, I thought of this essay by John Durham Peters called "The Gaps of Which Communication is Made," and he makes in his book Speaking into the Air, he makes this argument that he makes this distinction between communication singular and communications plural, and communication he defines as a reconciling self and other, and communications are the institutions and technologies that we build as societies of increasing scale to try to continue to solve the problem of communication, of reconciling self and other, and that isn't never accomplished, that there is always a gap. There's always, you're speaking into the air, in other words. And so I think I kind of like that idea that the gap continues, that there's a gap in which we don't know the world, and there are these gaps that are, they're mysteries and should remain such. It's one of the things that I was kind of alluding or implying when I said that I didn't think we should design technologies to read minds. I don't think we should read minds. I think it's not that what's inside someone's mind is a mystery. It should remain as such, and it's also problematic to think that we can actually do it. So.
You used the word interpretation at that point. You were emphasizing the fact that these technologies are always staging interpretations.
Yeah,
I think is interesting because it reinterjects a sort of a hermeneutic idea that is often absent from the way these technologies get presented publicly as in the news and in conversations about security apparatus.
Right, and actually that makes me think about a difference between something like a polygraph, which creates measurements that have to be interpreted, and same with fMRI, and the effort of sort of actually to automate facial expression analysis, where they're trying to design in the interpretation as well, in addition to the measurement.
Mm-hmm. Lev, you look very thoughtful.
Oh, yeah. Okay. Well, I guess I just want to say that maybe just to make it clearer that in my case, the kind of gap or the distance I was talking about, it's not the gap or distance between humans and machines.
Mm-hmm.
Because we've been symbiotic for 60 years, and basically, I think that, the brain is a super complex computer, and we haven't figured out how it works, and it's possible in the next 50 to 100 years we'll figure it out, but it's hard to imagine it's otherwise. So the gap I was really talking about is the gap between the kind of knowledge, right? The information and the knowledge which we can obtain, kind of using our senses, right? And being part of a community in a way it is, let's say, how much my friends know about me or how they understand me, or professional ethnographers, which probably have various other skills, and we can imagine this professional ethnographers being dropped, I don't know, from professional ethnographers from Mongolia being dropped in California, trying to understand it, right? Versus what, let's say, the same people can learn about California by never leaving Vietnam and just having access to, all the possible kind of records and traces of our existence being captured on cameras, in the left in the emails, Facebook conversations, etc. And just thinking over what I said, I wonder if you can actually learn much more, and the knowledge you can obtain about a society, a group of people, individuals would be actually much more precise and much more precious for data analysis, because ultimately, but the point is that you can have to do this experiment, right? So now we begin to wonder how this experiment can be staged, right? Because until we do experiment, we don't really know, right? And perhaps, our assumption that the insertion itself inside the situation produces better insights, it may be completely wrong, right? And I just want to maybe finish by saying that what kind of project, you and me, we've been doing at Software Studies we're applying kind of computational methods to analysis of various cultural artifacts, and some of these artifacts are very well known, like now we're working on all paintings of Van Gogh. Well, to a certain extent, it is this experiment, right? Because you probably had 10,000 art historians for 100 years studying at Van Gogh paintings and writing millions of books, and you and me are sure that we missed probably all the important things about Van Gogh. So in a few weeks we'll know, right? So then we'll know. So the question is, are we going to be able to, if we don't read these books, right, which of course is very hard because we're in our heads, right, we all look at Van Gogh, are we simply going to replicate the results? Are we going to disprove them, or are we going to produce something completely different, right? And that I think, so in some ways we are doing this experiment not with social data but with cultural data, right?
One thing that jumps into my head from the panel when I think about this, about these kinds of projects in comparison to, say, for example, the slide from Kelly Gates's presentation when you put up the slide of the security image, and the striking thing about the security image is it's so low resolution that I'm assuming, if I was interpreting correctly, that there are only 30 or 40 pixels maybe that are actually representing the face of that person that supposedly the facial algorithm would run on and recognize, which is ludicrous. The information is simply not there. So sometimes a technologist might respond to this and say that we're talking about that this is a quantitative gap, right? We just need higher and higher and higher resolution cameras and cameras in more and more places, and eventually we will be able to feed the algorithm with the information it needs, the closing the gap between the conference Lev talked about, the conference that's remote and the conference that's in person. But Lev, you're talking about something that is in some ways, if not qualitative, it's just methodologically really distinct in that the research, we're not trying to get to the point where the camera is seeing the Van Gogh painting as well as a trained researcher in the gallery, but we're talking about something where you're looking at every painting all at once, and you're sort of looking, it's about a kind of a defamiliarizing and transverse gaze rather than being kind of deeper or shallower, nearer or far.
I would also add that, there is this kind of assumption which is repeated in millions of books, right? That the humans are very good at pattern recognition and computers are very good at computation, at counting. And actually realize very often it's completely reverse. And the humans are only good at recognizing differences if we have few objects and the differences are very big, right? So I can recognize that you guys have different faces, right? But if I give you, 1,000 paintings, which are very similar in color and tell you which one is the most colorful, computer can tell like in a millisecond, but human can't, right? So all these assumptions we have about computers and humans and the gap, it's all kind of questionable in a way.
How does this fit into your reading of sort of Negroponte's stages of thinking about what you described a lot of frustration with computer perception and the ways in which computer perception was able to aid the design processes he was interested in.
He was interested in this idea of, again, symbiosis, which he takes from Licklider and puts and tries to interpret in his own view of an architecture machine. But a lot of it does roll down to let computers do what computers are good at and let humans do what humans are good at. I think one of the interesting things about Levin Kelly's work is that it draws into question just what those things are to the point that Lev just made. But yeah, he I think the thing that I found most fascinating, or that one thing I find most fascinating about some of these early writings he did, was the idea that he was pretty certain that in order to, you really did need to situate intelligence in a body that was rather like a human body or was a human body. And the other aspect I think that's particularly rewarding about his early work is that he questioned what the nature of intelligence was and decided that it had to be active. It's not a passive quality. And so those are some of the ways that he, I think, fusses with the notion of this gap and tries to bridge it and finds continual reasons for it to fall apart. He points out today that there isn't anybody that he can think of at the Media Lab who's working on, questions of the nature of intelligence, although I think you would find it in the AI lab and some of the bigger cross
What do you
Unitarian
mean?
initiatives.
People like Minsky or people like Pepper, who basically influence all of them, right?
Exactly. Yeah.
People who ask more fundamental questions.
Yeah.
Well, even Alan Kay, right, who was only able to design, who actually turns out was here yesterday, we all missed it, who was only able to make a computer which works because he based his work on the kind of theories of cognitive psychology, right? And he studied very deeply, and that's why the machine actually works.
Right.
Right.
And that's also another aspect, is modeling is a very important idea. What Negroponte was modeling something on, and how they're using cognitive psychology at that point in time. I was struck also by what Kelly was saying about things becoming instantiated in, well, the politics of a situation being instantiated in the software you make to read a face, which is obviously the endpoint.
Mm-hmm. I was going to actually go back to the image that you mentioned, and this effort to use, well, the surveillance camera images are very low quality, and so there is a kind of these gaps, the things that Lev was talking about in terms of what you can get from them, and sometimes faces that are expressing don't express enough information to really get much to interpret. And so, there's something called micro expressions that, this idea that Paul Ekman came up with, that most people can't see them; they happen so fast, but computers could be trained to see them a lot better. But the question of low quality surveillance images is a really big one that's being dealt with a lot now, because the explosion of visual information that's being generated by surveillance cameras, and the use value they have to criminal investigations and other kinds of investigations. That image that I showed from the morning of 9/11 is actually a frame average. I read in Wired magazine that it was a frame averaged image. It's 7 video frames averaged together, so it would be even lower resolution and look even lower quality if it was just one video frame. So yeah, you can't get more information from that necessarily, but there are companies like Avid and software companies that are trying to develop technologies, use sort of repurposed digital nonlinear editing systems and other kinds of imaging technologies to try to deal with the problems of surveillance video. There are many, including the visual quality thing, but to kind of figure out how to make that whole thing that happens on CSI and on television crime dramas and movies actually happen, that you could get more information. And of course, obviously, surveillance video cameras are slowly being replaced with higher resolution cameras, but it's actually not the rule. I mean, there still is a lot of surveillance cameras out there that are, generating really low quality images. So there's not, there are lots of gaps in what you can learn from them, how they can't function as evidence of anything. They have to be worked on, and the work has to be done to transform them into evidence, to transform them into usable information.
One of the things that struck me about that, you speak a little bit about some of the dark side of building interpretation into the technology that is doing the perception. In a way, in some ways, the promise of that as an aid for design is also the danger of not actually talking about the fact that this is an interpretive technology. If it returns a bit that says terrorist or not terrorist, as opposed to returning the field of data of the face, and then different people with different algorithms argue over the way in which that field of information then gets interpreted. Yeah. And I was thinking, because my father was in the neighborhood of a set of text transformations on names, and so his name matched a name on the terrorist watch list, and he was held from a flight. And so that question, I was thinking of this in comparison to Lev talking about Nielsen, any set of comparisons or statistical characterization of a territory of faces or of a namespace creates neighborhoods, right? You get rounded into the same pixel as someone else. There's cheekbone profiling that's a byproduct of a Fisher face algorithm, or you have too many S's at the end of your name, and that matches a set of terrorist last name, and then you get the terrorist bit flipped. So I wonder how in some ways, this isn't just a question of resolution, but it's a question of, at any resolution, what is similarity? Like how does the similarity of the get defined by the technology you're using? Because that becomes the space.
And I think that this is where the question of letting computers do what they're good at and letting humans do what they're good at comes in as well, because humans are actually, I mean, computers will identify faces that look, two face. So when you do a comparison, what typically happens is you don't have a one-to-one match. If you're doing a one-to-many search, you'll get a set of results of possibilities from the database with like scores.
Right.
So it helps kind of narrow down the search, and then a human being can make the visual comparisons, and they're actually good at the subtleties and differences, ignoring ambiguities and things that that need to be ignored that computers aren't good at ignoring.
Yeah, I should maybe also add that we in our research in the lab we're using all exactly the same techniques. The difference is at the last step. I mean, basically, where we're doing, whenever you calculate similarity or difference between any objects, whether it is text pages or faces or bodies or paintings, you produce what's called a kind of similarity matrix, right? Which is a two-dimensional matrix, and then each cell is intersection between two objects, which may contain a number between 0 and 1, which tells you how similar we are, right? So the difference is that the computers are machines which are kind of developed to basically describe and capture ambiguity, right? Because everything is characterized in terms of continuous function, right? It's not 0, 1. You get a number, 0.99, 0.95. But the way these machines are used in our society is to basically threshold these results and just only give you this kind of binary result, right? So as you said, what you get is a list of these matches with probabilities, and I think some research engines are doing the same, right? Remember, like at some point, maybe even Google was doing it, right? It would give you, like a bar which would indicate, how strong Google believes that that's like the right result. But for various issues of efficiency, economics, and politics, more often this representation produced by computers when converted into kind of binary representation, right? Category A, category B, terrorist, not terrorist, Van Gogh, not Van Gogh, right? So to us it's very ironic that there has been a number of computer scientists working on using kind of computer vision methods to painting analysis, but it was all about basically identifying whether a particular painting was by Van Gogh or not Van Gogh, right?
Right.
And completely ignoring the fact that in fact computer produces this amazing kind of descriptions of this kind of subtle ambiguity, right? But things are not binary.
Okay.
So
there's some questions out there.
yeah. I think we're at a time where I think we have a few minutes. We have 10 minutes left, so maybe we should take a few questions.
Innocent, obvious question that's been answered sort of. We've seen so much of this in the past of technology.
Yeah, if you could just start over and with the microphone on for posterity.
Humans are.
Yeah. On the base of the microphone, there's a button.
I think this will be the 10 minutes right away.
There we are.
Is that it? Oh, good. Okay. Very obvious question, but since so much technology that came out of military research entered surprising aspects of our culture, and this technology is evolving, so what's the frontier of weird use that we might expect from this if all this data recognition and these similarity matrix systems really develop? What point of intervention might we expect? What pizza delivery offers? Or I have no idea what to even imagine, but you probably are encountering some of the oddities that are coming. I'm just curious, as a sort of lighter question.
Well, I think we're talking about maybe not only about points of intervention, but a very vast and very active currently kind of social and political discourses of movements, right? The whole discourse about data openness, maybe it is endless discussions with governments and companies should open their data, right? A project like Epider, endless projects to create open source, kind of publicly available visualization data analysis tools. So in fact, having these conversations that people should have access to their data and the data about them and the data produced by the government, and people should have literacy and the tools to analyze it. That's one of the kind of big conversations of our time in the last few years.
Well, I think that there's a lot of potential directions. And I mean, one of the things that was a little bit surprising to me initially, but now it seems so obvious, is that for facial recognition, for example, is now being integrated into personal photo management software. So we can use it on our Macs to identify our photos, organize our photos. And that, I think these kinds of applications are they're more effective in some ways in sort of introducing all of us to these kinds of technologies. I do think that pushing the sort of boundaries of it or thinking of it further, I mean, computer scientists are really interested in these kinds of technologies and have been over time, because they are interested in designing more intelligent machines and machines that can perceive, and so they are aiming to build in multimodal intelligent environments that can both identify individuals and kind of respond and interpret and respond to affective states. And I think it's hard. It's an excellent question. It's hard to envision what all of that's going to look like, but I do think I think that it will be very complicated, because all of that will delegate back onto us certain kinds of behaviors, and it'll just be a whole different kind of human machine subjectivity in a sense. I think that's.
And then there's the process of adaptation. In other words, as we adapt to what this does, then something else comes.
Exactly. It's really interesting.
Was there?
Can you? I'm sorry. Can you imagine these kinds of human-machine subjectivity situations in which contestation and contradiction could thrive? I mean, you're talking about situations where computers are not good at dealing with ambiguity, but I'm kind of interested in the alternative, the opposite of that.
No, I think I said that computers are perfect for dealing with ambiguity, because we produce continuous outputs. Okay. In fact, much better than humans. Humans are not as good at pattern recognition.
But is that at generating ambiguities or I mean, I guess, yeah, it's the situation of the role of interpretation and,
right.
and
Mm-hmm.
our position in relation. It's a very broad question.
Yeah.
I think that there are ways that computers have difficulty with ambiguities, certainly in the sort of trying to interpret expressions and the range of, sort of the range of ways that expressions look on different faces and things. And computers have a hard time distinguishing faces from background clutter. They have a hard time, because of and they can't interpret the ambiguities. At least the programs that are, being these kind of really preliminary kinds of programs that are designed to try to see facial expressions. I think that Lev's right, though it's more complicated than that. They have to deal with ambiguity, and they because the world is really ambiguous. So there's going to be all kinds of different manifestations of that, I guess.
I'm thinking about the different poles that they operate between. So when it's not just a matter of recognizing and making sense of points on a face or face from a background, but also figuring in the social network as per James's presentation earlier today, and all of the different kinds of social data that might be connected to that individual, and how we might in turn play with and hide behind those ambiguities, I think are interesting questions.
Yeah, I think this is, and we have time for this is the last question.
Humans are ultra focused on being able to recognize faces. Do you have any feeling for how good computers are, say, at distinguishing gerbils' faces compared to how good humans are at distinguishing gerbil faces?
I don't know that anyone's done that research, probably, but I don't know of it.
In other words, pattern recognition in general,
right,
versus just faces.
I mean, it's a good question. I think that one of the reasons why computers are probably better at identifying human faces than gerbil faces is because there are certain range of social necessities around facial recognition, and there's long traditions of facial portraiture and identification and use of photography for identification and standardizing identification procedures using faces and standardized formats for capturing them visually. So I don't think they have the same database to build from gerbil faces.
Well, I think in my understanding, kind of looking at this literature, particular problems in computer science, people have solved them better simply because people put more work into it, right? I mean, people started working with, probably in the second part of the 50s, so maybe have 50,000 like academics and PhD students working with for 50 years. So of course it's going to work. If people spend 10 years on, mouse faces, it's going to be even better, right? It's all depends on what society wants, right? So that's why you have certain problems, certain computational problems which are solved and certain which are not. It depends, like society kind of has this flashlight which points at people what to work on, right?
Yeah, and I think this is a good moment to wrap up, because the questions all kind of also point towards this feedback loop, the feedback loop in research, the feedback loop in what the data people make themselves. Once I realize my photos are being read by an algorithm in my media collection algorithm, I start taking photos differently, yes, so that they can be read by the algorithm in my media collection, and the way that we then iterate that constellation of algorithms as a kind of vocabulary going forward.
In the early 80s, I think, when this was all getting started, Jean Baudrillard, who is known for very provocative and sometimes very extreme statements, said, he was like looking some American documentary programs about children, kind of, right, getting computer instruction. He said, this is not a computer teaching child, this is computer teaching child to behave like a computer. But now, 30 years later, somewhat is coming to true, right? Because we interact more with computers than any human beings, and we have to adjust to them. We have to adjust to software systems, the way we're designed.
So thank you all for coming, and thank you to the speakers. I'm sorry, did you want to add?
No, that's great.
Okay,
thanks.
Then I think thank you, and looking forward to the rest of the conference with you. Thank you.